Good afternoon, everyone. Today I will present how the responsible AI can help to improve the credit card approval decisions at ABC Bank while ensuring fairness, transparency, and regulatory compliance. The business context of this project is based on a scenario at ABC Bank. Currently, the bank credit card approval process rely heavily on a manual review. While manual decision-making provides a certain level of control, it also introduced a serious challenge. First, manual approval is relatively slow and labor insensitive, which increase the operational costs. Second, the decision standards may vary across different reviewers, which can lead to inconsistency in approval process. Third, in financial services, both human decisions and algorithm system may introduce potential bias and compliance risks if they are not carefully monitored. And also for the project objective modeling workflow, and objective of this project is to predict whether a credit card application should be approved or rejected. The target variable is binary, where 1% approved and 0% the rejections. To address this business problem, the project followed 5 key stages. First, the exploratory data analysis was conducted to understand the application profile and assess overall data quality. Second, a structured data processing pipeline was built to clean the data, prepare the variable, and contrast the features that better capture the applicant's financial suitability. Third, multiple machine learning models were evaluated to identify an approach that balances predictive performance with governance requirements. Fourth, model performance and generations are assessed to ensure the model can perform consistently on unseen data. Finally, the most importantly, the responsible AI methods are applied. This includes fairness evaluations, biomitigations, and model explainability. This framework ensures the model is not only the predictive, but also a transparent, accountable, and suitable for deployment in regulated financial environments. Um, Also, we have the EDA part that this data contains around 900 and 700 credit card applications where the target variable indicated whether an application is approved or rejected. One important observation is that the dataset is highly imbalanced. About 80% of the applications are rejected, but only 13% are approved. This means a model could achieve a high accuracy simply by predicting all applications as rejected. Therefore, accuracy alone is not significant. And we also consider metrics such as the precision we call an F1 score. Looking at the features, we found that some numerical variables such as income and employment length are string and contain outliers, while several categorical variables have uneven category distributions. And also for the data processing and feature engineering part, first, the ID variable was improved because it does not contain a meaningful business information and may cause the model to memorize the individual records. Second, missing values are handled by using a median imputations and numerical features, and most frequent value for categorical features. First, numerical variables were standardized, while category variables are encoded using binary encoding, which helped reduce the demonstrations compared to traditional one-hot encoding. Fourth, 2 additional features are created to better capture the financial suitability. The first is the income per family, which represents household income per family members. The second is employment age ratios, which reflect employment stability relative to the age. Finally, the feature selections were applied using the select KB bars with a mutual information to retain a most informative variable. Also, for the model deployments and evaluations, I first trained a baseline model using a logistic regressionist, although the model achieved an accuracy of around 0.87. Further analysis showed the precision we call F1 score was close to 0. The confusion matrix indicated the model predicted almost all applications as rejected. This result highlights important issues. Accuracy can be misleading. Highly imbalanced data set. To improve the model, I compared 5 algorithms. logic regressions, decision tree random forest with SGP a lot GBM. The comparison shows that while most models achieve relative high accuracy, their recall and evidence score for the persistent class remain low. In addition, the overall ROC AUC range between the 0.51 and 0.58 suggests that there is a challenge prediction task. Based on this result, I select large GBM as the final model and apply hyperparameter turning together with the smooth to address this class imbalance. Although the improvement in overall predictive power was limited, the model shows better ability to detect the miniature case. More importantly, this data helped establish a more robust and transparent modeling framework for the later responsible AI analysis. Also, to further evaluate the model's learning behavior, a learning curve analysis was conducted. The result shows that the training models decreased from the 0.2 to around to 0.7x. The training data set increased, while the validation score gradually improved from the approximately 0.53 to 0.58. This indicated that the model became more stable as more data is introduced, suggests improved generalizations. At the same time, the training score may consider higher than the validation score, which suggests a model level of overfitting. From a business perspective, this means the model has learned meaningful patterns in the data but is not strong enough to fully replace human decision making. Instead, the model is better positioned as a decision support tool that can help prioritize the application, highlight potential weaks, and assist analysts in making more consistent decisions. Also, for the responsible AI, which is critical for deploying AI models in financial institution, in any decision is not enough for a model to a predictive. Automated system must also be fair, transparent, and compliant with regulatory requirements. To evaluate the fairness, we analyze how the model performs across different demographic groups, partial gender and age segment. These results show the model treats male and female implication very consistently, indicating a strong gender fairness. Across age groups, the differences are relatively small, although the younger application shows a slightly higher approval success rate. While these differences are not large enough to suggest discrimination, they highlight the importance of the continuous monitoring while AI systems were used in lending. To further strengthen fairness governance, bias mitigation tactics were applied to reduce the disparities across the groups while maintaining the stable model performance. For a business perspective, this AI approach provides the important benefit. First, it helps reduce regulatory and compliance risks associated with automated lending decision. Second, it improves the transparency and accountability in AI-driven decision process. Third, it enables the banks to deploy the AI responsibility while maintaining human oversight. Also, for responsible AI transparent credit decisions, the final component of this project focus on the model explanatory, which is essential for a responsible AI deployment in financial institutions. In credit decision system, it's not enough for a model to make accurate predictions. Bank must be able to explain why the application was approved or rejected, especially when responding to the customer or regulatory audits. At the portfolio level, global reputation technique shows that account history and income level are the strongest drivers of the approval decisions. For example, account level has the highest importance score at approximately 0.01, followed close by the total income at around 0.015. Other influence factors include the occupation types and income types. Each contributed roughly 0.01 to model performance. And the employment stability also play an important role. Features such as employment age ratios and year employment contribute around 0.05 and 0.06, indicating the applicants with a longer and more stable employment history are more likely to improve. At the individual level, local inspirations allow us to understand why a specific application was rejected. And additionally, The financial indicators such as the income per family and account left contribute around 0.31 and 0.21. These expressions allow the bank to clearly understand how different financial factors interacted to produce the financial decisions. From a business perspective, experimental AI improves transparency, support regular audits, and increase trust in AI-assisted lending systems. And also, first, regarding the responsible AI principle and values, we evaluate whether the model treats different customer groups consistently. We analyze the model outcome across the gender and AI and compare the fairness metrics such as the selection rate, true positive rate. The results show that the model performance consistent across the gender and only minor difference exists across the age groups. To further improve the fairness, we apply a bias mitigation strategy, which helps reduce the disparity between the groups while maintaining stable model performance. This process helps ensure the model aligns with a fair lending principle and regulatory expectations in financial institutions. And also for the improving the model explanatory, we employ both global or local explanation techniques. Global explanation helped identify the key drivers of the credit approval decisions, such as account history, income level, and employment suitability. The local explanation allow us to understand why specific applications was approved and rejected, making the individual decisions transparent and interval. Together, this explanatory tool enable transparent, auditable, trustworthy AI decision making, which is essential for responsible deployment in real bank environment.